Today, we're going to be going over the Auto Evals feature on Inference.net. This is one of our two current evaluation products, the other being Direct Evals, and it's essentially a way to explore other models for a given task. You can view how different models vary in quality, similarity to your currently used model, latency, and cost. The best part of this is that you don't need to set up any sort of environment, rubric, or other code besides the integration itself. Auto evals themselves work through simulating responses using the original query or trace, and then using LLM as the judge to grade the nature of those outputs. To begin with, you should modify your code to either use our gateway or tracing integrations. If you're generating single-turn LLM responses, you should plug in our gateway with the following code snippet, which involves modifying the base URL, using our API key, and setting some headers. For the tracing integration, you can import our tracing package and integrate with the pattern as shown. For more details on integration or quick ways to do it with AI, check out our docs at docs.inference.net. From there, you will see your data loaded as either a task or an agent depending on how you integrated. If you click through, you'll see this tab at the top that says Compare Models. If you click that, you'll be greeted with the following screen. In order to kick off a run, you're going to hit Run Comparison, and you can modify these configurations accordingly. Here, you could change the traffic window or the samples per model that you're going to generate. I usually recommend about 100. Then you can select the models that you want to evaluate, and in this case, we usually provide a list of recommendations. So here, I'm going to go and modify, maybe deselect a few of these models, select this, and I'm going to go and kick off a run. Usually this takes about a few minutes to complete, and I'm going to go ahead and fast forward so we can see the results. Alright, now that the run is completed, we can see the set of recommendations and insights that this auto eval run provides us. The headline is that for this task, we should use GPT 5.6 Luna. And for a little bit more context, this was a coding harness task where we used GPT 5.4 to do security audits of a bunch of open source repos. So it's fairly complex. Again, out of the models we selected, it found Luna to be the best, especially optimizing for quality. We have a set of key findings here that talk about all the models, and it's things like, Grok 4.5 was pretty close, and Gemini 3.5 and 3.6 Flash are perhaps worse at things like JSON validation. We have an overall run summary down below that, and kind of the meat of the eval is in the graph and this table right here. This graph shows you cost versus accuracy, and maybe it's familiar, it's like the very artificial analysis style of graph, and you can see this sort of Pareto frontier curve where maybe DeepSeek V4 Flash is the best model if you want the absolute cheapest that is still somewhat good, but Luna is probably the best balance of still cheap and the best out of all the models here. And especially, comparing it to our current model, it's a no-brainer to switch, right? It's better and it's a lot cheaper. In the table, we have specifics on the quality and similarity. Again, quality is how well the model did on the task, irrespective of anything else. And similarity is comparing how similar this model response was to our original model that we used to generate the traces. We also have some more information on latency and price. But as we go down here, these are more insights on specific traces where it's falling short. One thing to call out, this is still in beta, so you might see this dashboard change a lot, but always the thing to look out for is going to be this graph and table right here. And, as another thing, you can click down and get specific paragraphs about how each of these models performed. Now, if you want to go into the specifics and look sample by sample, we have a sample viewer right here that you can open up and actually look through each of these traces to see how the models responded. You see the context built up here, and you can go ahead and select through all the traces or kind of just flip through them. And as you go down, all the model responses are produced side by side. We have the judge output on the top right, and you can just go ahead and scroll down. Maybe if you want to add a model or deselect a model, you can modify it right here. And most importantly, if you want to sort by any model, and maybe I want to see the worst responses for GPT 5.4, our current model, I'm going to go ahead and click ascending, apply this filter, and now we can see all of the models where we're currently failing. And this is one response where it got a 3, but as we scroll down, we can see that Luna got an 8, an 8 quality score. So a lot of these samples where it's currently failing, Luna's able to pick up the slack. So this is a really powerful tool for actually getting an intuition on how these models respond in different situations. Overall though, this is a really powerful tool for quickly figuring out what model you should be using, and particularly how you're going to balance this trade-off between cost and accuracy. I'm sure if we put in more models like Terra and Sol, they probably would have been higher quality, but maybe the price wouldn't have been worth it, and you're willing to take a slight hit on quality if it's something that's 2 to 3x cheaper. That's really up to you to decide, but all the information is out here, and we do provide our best recommendation on what we think you should be using. When you do make the decision to switch, you can go ahead and click this button, and it's as simple as switching the model identifier. Here we have a prompt that you can pass into Cloud Code, Codex, Cursor, and what it does is it essentially finds out where you're calling this model and just switches it to the respective model ID. And because of how our gateway works, you route through us and everything just starts going to whatever model you selected. It's not a lot of work. You have all these options available, and again, if you don't want to modify the code yourself, just copy this prompt and put it in your coding harness. So yeah, I hope you guys enjoyed this overview. Again, if you want more information, check out our docs at docs.inference.net. There we have more specifics on how to actually use these tools, what specific tricks might be, and kind of more pros and cons of this sort of evaluation approach. Thank you guys, and stay tuned for future videos.